Hello students, welcome to this session of quick solution of All India AIATS test series for JEE Advanced 2020, Test 4A, Paper 2, Code C and D, Subject Physics, test dated on 24th of November 2019. Straight away, let's start with the question number 1. Here in question number 1, in Bohr's hydrogen, an electron makes a transition from energy state n is equal to 6 to n is equal to 4 and consequently it emits a photon of frequency f. Now let f4 is the frequency of circular motion of electron around the nucleus in n is equal to 4th energy state. The ratio of f4 divided by f is equal to k. Then find the value of 10k. Well, I would say the electron is making a transition from n is equal to 6 to n is equal to 4. So simply let f be the frequency. I would say h into f would be equal to delta E naught into 1 by 16 minus 1 by 36, or it will be delta E naught, here it is 4 will be taken as common, that means it is 1 by 4 minus 1 by 9, or HF it would be delta E naught 4 and this is 5 divided by 36. This is one of the calculation for the frequency of the emitted photon. Now, in next stage of calculation, we need to find the frequency of the electron that is actually rotating in energy state n is equal to 4. So there, I would say F4 would be V4 divided by 2 pi R4. What we know there, angular momentum that happens to be mv4 R4 must be equal to 4h divided by 2 pi. Now, just try to put the value of R from here. It will be F4 is equal to V4. It is 2 pi. Value of R4 would be 4h into 2 pi into mv4. This will cancel out and we are having mv4 whole square divided by 2 into 1 by 2h. This is the value of F4. What we know here, this being the kinetic energy, this mv4 square divided by 2 is the kinetic energy in the fourth state. It will be equal to the magnitude of the total energy in the fourth state. So I would say F4 would be delta E naught divided by, in fourth state, it would be 16. That's the energy state there, into 1 by 2h. So now taking the ratio of F4 divided by F, F4 divided by F, it is delta E naught divided by 16 into 2h, and F here we have calculated, it is 5 delta E naught into 4 into 36 into h. This part will cancel out. This is h will cancel out. Here I will have 4 and this one is 9. So I am getting here 9 divided by 10. This is the value of k. So on multiplying this value with 10, I'll be getting the answer 10k is equal to 9. That's the answer for the question number 1. So here 9 is the final answer. Now let's proceed to question number 2. In question number 2, figure below represents the layout of Lloyd's mirror experiment. S is a point source emitting wave of frequency 6 into 10 to the power 14 per second. A and B represent the two ends of a mirror placed horizontally, and LOM represent the screen. The distance SP, PA, AB and BO are 1 mm, 5 cm, 5 cm and 190 cm respectively. Determine the width of region in centimeter on a screen where fringes will be visible. We shall have the small diagram here. Just by looking onto the diagram, perhaps we may be able to find out that how much distance on the screen the fringes will be formed. Well, this will be the reflected ray here from this point, and for this point here, this will be the reflected. We need to find this distance. Fine. Here, this distance being how much? It is 1 mm. This distance is 5 centimeter. This is also 5 centimeter, and this is 190 centimeter. So for the reflection of this light, I would say let this distance from here to here, it is y1. I would say y1 divided by 195 would be equal to 1 mm divided by 5, or y1 is equal to 195 divided by 5 mm. Similarly, for this reflected ray, I would say y2 divided by 190, this is 190 here, it must be equal to 1 mm divided by 10. So y2 is coming out to be 19 mm from here to here, and this one from here to here, the y1, that is coming out to be 195 divided by 5, that is 39 mm. So this much of the distance, that is actually we are getting here y1 minus y2, it is coming out to be 20 mm. So in centimeter, we shall have this answer as how much? It is 2 centimeter. So for question number 2, we are getting the answer as 2. Now let's proceed to question number 3. In question number 3, when a beam of 10 electron volt energetic photons of intensity 2 watt per meter square falls on a platinum surface of area 1 into 10 to the power minus 4 meter square and work function 5 electron volt. If 80% of the incident photons affect into photoelectrons emission, the maximum possible energy of total liberated electrons per second is K into 10 to the power minus 5 joule. Find the value of K. Let N be the total numbers of the photons that is actually incident on the metal surface. So simply I would say N into energy of one single photon, that happens to be how much? It is 10 electron volt, divide by A into delta T. This is the intensity that actually being mentioned here as 2. Fine. Now further, so that means N divided by delta T, that is equal to 2 into A divided by 10 electron volt. This is the total number of photons that is incident per second. It's been said that 80% of the incident photons affect into photoelectron emission. That means the total number of photons that will be emitted, it will be 80% of this number. So simply I would say N divided by delta T into 8 divided by 10. That means 2 into area divided by 10 electron volt into 8 divided by 10. This is the number of photons that will be emitted from the surface per second. Now for further calculation, we need to find the maximum possible energy of total liberated electrons per second. The one electron shall have 10 electron volt minus 5 electron volt of energy. That means 5 electron volt of energy. That is the maximum possible energy here. So this much of the photoelectrons will be emitted from the surface. So I would say the maximum possible energy would be 5 into 2 into 8 into A, this number, divided by 10 electron volt into 10. This is the maximum possible energy that will be emitted from the surface, and surface here that's already been given as 1 into 10 to the power minus 4 meters square. So I would say this is the energy liberated per second. So just have the calculation here. This 10 will cancel out. We are having 8 divided by 10 into area being 10 to the power minus 4, or simply it is 8 into 10 to the power minus 5 joule per second. So matching this answer with the one given here in the question, we are getting the value of K to be 8. That is the final answer. So for question number 3, 8 is the answer. Now let's proceed to question number 4. In question number 4, a narrow monochromatic beam of intensity of I is incident on a glass plate as shown in figure. Another identical glass plate is kept close to the first one and parallel to it. Each glass plate reflects 40% of the light incident on it gets reflected and remaining gets transmitted. So let's say initial amplitude is A0. I would say A0 square would directly be proportional to the original intensity I. So Here initial part A naught is the amplitude. Transmitted light would be how much? 60% of the incident one. So here the first one, the amplitude would be root under 6 divided by 10 into A naught. And along the direction, this first reflected amplitude will be how much? This one is A naught root under 4 divided by 10. Further, on this side, on second reflection, this portion will have root under 6 divided by 10 into root 4 divided by 10 A naught. And yet again, when it will be transmitted along the direction, this portion will have here this one. It will have root under 6 divided by 10, root under 4 divided by 10, root under 6 divided by 10 A naught. So what we are getting effectively, these two waves, this one and this one, having the amplitude that's actually being presented here. So we shall have the interferences of these two portions. So I maximum and I minimum will directly be proportional to the square of the resulting amplitude there. So I would say I maximum would be when the constructive interference will take place, we will add these two portions of the amplitude and square them. So what I will have here, it is A naught square into 4 by 10, and this is 1 plus it is 6 by 10 whole square. Similarly, I minimum I will have here as A naught square 4 divided by 10, then 1 minus 6 divided by 10 whole square. This is the ratio of I maximum divided by I minimum. These two will cancel out, and I'm having this ratio as this is 10 plus 6, 16 whole square, and this is 10 minus 6, it is 4 whole square. So it's coming out to be 16. Fine. This particular answer has been given as 2K. Just see here. So definitely I would say the value of K to be how much? 8. So for question number 4, I'm having 8 as the answer. Now we shall proceed to the next question, that is question number 5. When an alpha particle collides with a stationary lithium nucleus, the following nuclear reaction may take place. He4 plus 7 Li, it actually forms the 10B plus 1 neutron. Q value of this reaction is E is equal to minus 2.865 mega electron volt. If minimum value of the kinetic energy of incoming alpha particles required for this reaction is E naught in mega electron volt, then find the value of 2 E naught. Well, here we can say that for these two systems, energy with respect to center of mass of these two systems must be at least of that much of the magnitude, which is given here as 2.865 mega electron volt. So first I would say 1 by reduced mass of these two systems will be taken as 1 by 4m plus 1 by 7m, where 4m I'm taking this to be as the mass of helium nucleus, and for 7m to be of lithium. So that means it is 11 divided by 28m, or m reduced, it is 28m divided by 11. So the energy with respect to center of mass, it will be 1 by 2 into 28m divided by 11 into V naught square. It must be equal to 2.865. That's the thing I'm saying here. So write it down, 1 by 2 4m V naught square into 7 by 11 is equal to 2.865. This portion, it is actually the energy of the incoming alpha particle. So it must be presented as E naught. So I would say E naught must be equal to 2.865 into 11 divided by 7, or 2 E naught will be how much? It is 2.865 into 11 into 2 divided by 7. On calculation, we shall be getting this value to be somewhere around 9 mega electron volt. So clearly I would say for question number 5, I'm having this answer as 9. Now we shall proceed to the next question, that is question number 6. Here in question number 6, a beam of light consists of two wavelengths, 6300 angstrom and 5600 angstrom. This beam of light is used to obtain the interference pattern in YDSC. If fourth bright fringe of 6300 angstrom coincides with nth dark fringe of 5600 angstrom from central line, then find the value of n. I would say that from this line, if fourth bright fringe of 6300 angstrom, that means I need to find the fringe width for this one. It is lambda d divided by small d, lambda being 6300, d divided by small d. This is the fringe width. It's fourth, this one is actually coinciding with nth dark fringe of 5600. It is there, the fringe width will be how much? 5600 into d divided by d. So nth dark fringe, that means it will be half of the fringe width, and odd multiple nth, that means it is 2n minus 1. Fine. Now this would cancel out, this 0 will cancel out, and I'm having here as 63 into 8 divided by 56 is equal to 2n minus 1. So I'm getting n is equal to 5. Is that clear? So for question number 6, our answer is 5. Now we shall proceed to the next question, that is question number 7. Here in this question, the minimum thickness of the film D is equal to K divided by 10 root 2 micrometer of refractive index 3 divided by 2, at which light with wavelength of 0.8 micrometer experience maximum reflection, while light of wavelength 0.4 micrometer is not reflected at all. The incident angle of light is equal to 30 degree. Find the value of K. We shall have a slight of elaboration here. If this is the incident light, once reflected it will move along the direction, further along the direction, and this is the way it will be reflected. So if these two light, if they are interfering in a constructive manner, we shall have the maximum intensity and the maximum reflection will take place. Or if it is interfering in a destructive way, then we shall have the minimum intensity in reflected side. So at least if you make this calculation, what you will be getting there, if this distance being d, then the total path difference of these two lights, including the phase shift that will be bearing because of this reflection, we shall say it is 2d square root of mu square minus sine square theta. So for the constructive interference, taking care of the phase difference that will be appearing here, n plus 1 by 2 into lambda, this is the condition for constructive interference to happen. And for destructive one, it will be 2d root under mu square minus sine square theta will be m into lambda. Now n and m must be the integer value function. Taking care of these two parts, what I'll be saying, it is 2d here, mu, we already had the answer for mu, that is 9 divided by 4 here, sine square theta, theta being 30 degree, I would say it is 1 by 4, or it is 2d, this part is 9 minus 1, 8 divided by 4, it is root 2. So what we shall say, this portion is n plus 1 by 2. Maximum interference is happening for the wavelength of 0.8 micrometer, and 2d root 2 is equal to m into lambda for destructive interference, that is happening for 0.40 micrometer. Just looking at the option, it is very clear that minimum value of m and n that will satisfy this equation, that is n is equal to 0 and m is equal to 1. Clearly? Fine. So now, putting the value of n is equal to 0 here or m is equal to 1 here, I will have d to be equal to 0.40 into 10 to the minus 6 divided by 2 root 2, or it is 2 into 10 to the minus 6 divided by 10 root 2. Just compare this answer with the one that's been given here. So clearly in numerator, this portion k, that happens to be how much? It is 2. So I would say k is equal to 2. For question number 7, we are having the answer as 2. Now let's proceed to the next question, that is question number 8. In question number 8, In a protonium atom, a proton and an antiproton orbit each other, assuming the quantization of angular momentum would remain valid if it's been supplied with slightly greater than 12.23 kilo electron volt of energy in its ground state so that it jumps to mth energy state. Then find the value of m. In this part, if we make some rigorous calculation taking care of force of attraction and the integral multiple of nh by 2 pi s angular momentum, then we will be getting the energy in nth state would be equal to minus of delta E naught into 1836 divided by 2n square. Delta E naught is 13.6 electron volt. So what I will say here, if 12.23 kilo electron volt of energy it's been supplied with, then it jumps to mth energy state. So simply from 1 to m energy state, it would be delta E naught into 1836 divided by 2. It is how much? From 1 to m. I would say 1 minus 1 by m square. This energy is coming out to be 12.23 into 10 to the power 3 electron volt. If we make the calculation putting the value of delta E naught, we will be getting m square to be almost equal to 49, or I would say m is equal to how much? 7. So the value of m here in question number 8, that is coming out to be 7. That's the answer for question number 8. Now we shall proceed to the next question, that is question number